Hi, welcome back to my channel. This is Kidomuju from KD Concept Researchers. Please kindly like and subscribe to our channel so that you can always get our videos while it drops.
All right. Welcome back to the second part of our series on data analysis. Especially, we are considering how to analyze survey data. That is data obtained from a survey process. This survey, we are using a questionnaire, and then this questionnaire has about 16 questions all entered into SPSS, starting with the demography, which takes care of our A, section A. We also have section B, our section C, D, and section E, and every question entered. Now, it's interesting to know that from section B, we have the Likert scale from strongly disagree to strongly agree. So these are the four options that a respondent can answer the questions. So they are going to answer based on what the best think is the right one. So from strongly disagree to strongly agree. Now, after we entered the questions, we were not able to feed it with some variables here, just some data, random data. Remember, this data are not actual data. We just want to use it to test run the behavior of the questionnaire. Okay, the first thing you may want to do is to get your descriptive statistics. How do we do that? Now you can toggle here to see how each of these responses were entered from respondent number 1 up to the very last respondent, which is number 100. We're just considering 100 responses here. So to get the descriptive statistics of all data field here, we'll go to analyze, then we'll go to descriptive, go to frequency, which is very important. I'm going to reset this. Now click on the first one, hold your shift and click on the last one to select all variables. Move it to the right. Now go to statistics. You can set it to calculate both mean and standard deviation. Right now, I don't really want charts, but if you want charts, you can come to charts and select either bar charts, pie charts, or histogram. When you're done with that, you click on OK. Now go back to our result view to see the results we have obtained from this survey. Now, this first table here is the statistics showing you how every data, every variable was entered. You can see that the sample size is 100, and this is same across the column. And then we also have that there is no missing number. So all 100 participants' responses were used in this analysis. Down here, we'll have the mean and standard deviation for each of them. Now, going down, we see a full frequency distribution of how each response was given to each particular question. You can see the first one here is on age of child, and the age range from 3 years old, 4 and 5 years old. You can see the frequencies and percentage. The same goes to gender, educational level, and occupation, and that is our demographic data. Now, from this table here, which represents our B1, you can see the actual questions and how they were answered. Like for instance, on this question, I'm aware of the term malnutrition. 20 persons strongly disagreed, 20 persons also disagreed, while 30 persons agreed, and also 30 persons strongly agreed. Represented here is also their percentage. Now, if you go down, you also see how every other question was answered. So this frequency table is the first thing you need to get for your questionnaire, because to represent the responses from your questionnaire, you use your frequency and percentage. Two very important statistics which you can use is your frequency and percentage. So that is it with how to obtain the frequencies of a survey data. Now let's go back to the actual data. Now, another thing you want to check is if there is a positive or negative relationship. Let's just say there's a relationship between these questions, and that will lead us to correlation analysis. Now, with correlation analysis, you can check for the relationship between each of these questions. Again, how do we carry out correlation analysis? Now, we'll go back to our analyze, then go to correlate, and choose bivariates. I'm going to reset this table. Now, I just want to correlate from my B to my E, so I don't need to add the demographic data. I will select with my shift from B to E, move it. Now, SPSS is asking us what correlation coefficient are we looking at? We are looking at Pearson correlation coefficients, and then we are looking at it for two-tailed test. Remember, you also need to flag that significant correlation should be flagged. Everything is all set. I'll click on OK. We now move over again to our results window. Now, this is the correlation analysis. As you can see here clearly, that there are both positive and negative correlations. For instance, the correlation between I'm aware of the term malnutrition and I'm aware of the different type of malnutrition is negative. That means there's a negative relationship between the responses of people who are aware of the term and the various types. It is significant, showing that possibly those who claim to be aware of the term malnutrition are not so much aware of the different types of malnutrition, such as severe acute malnutrition, moderate malnutrition, and chronic malnutrition. So that is why we have a negative correlation. However, if you look at the correlation between I'm aware of the term malnutrition and I'm aware of the signs and symptoms of malnutrition, we see that this is a positive correlation of about 0.582, and this is a positive correlation. Now, this simply states that awareness and knowing the symptoms has a positive relationship. That is why this correlation here is positive and it is significant. How do we know it's significant? You see that it is starred. It is starred double. That means it is significant at 1%. If you scroll down, you find out other correlations and their significance. You can also see that there's always 1, 1, 1 on the leading diagonal. Now, this one represents correlation of a particular question with itself, which is perfect correlation. That is why it is 1. You can see it on every line. You see that correlation. Okay, so this is about correlation on survey data. Now, let's go back to our main data. Another thing we want to check now is if there is significant difference amongst these questions, how they were answered. Like in section B, was there a significant difference between responses on B1, B2, and B3? And also in C, D, and so on. Now, to check for significant difference between responses on the same group, we have to use a non-parametric test called Friedman Test. Mind you, we are using non-parametric tests because our assumptions for ANOVA is not certain here. Assumptions such as normality and heteroscedasticity is not in place. So when those assumptions are not known, it is best you use a non-parametric test. So which non-parametric test are we using today? We are using the Friedman test because the Friedman test is used to compare for difference between same group, while the Kruskal-Wallis is used to compare for difference among groups. So how do we conduct a Friedman test on section B, for instance? We'll go to analyze. Then down here we have our non-parametric tests. Then you go down to legacy dialog. The very last one on the list is K-related samples, and that's what we are going to use. Now, what are the related samples here? Related samples are the questions in section B, starting with B1 to B3. So I will highlight the three of them, move it to the right. So I want to check how these questions were answered, if there's significant difference in the way they were answered. Now I'm going to be testing that with my Friedman test. I'll click on OK. Again, we switch over now to the results window to see. Now this is the Friedman test for section B. You can see their ranks here for each of the three questions. Our interest lies in the test statistic, the Friedman test statistics. It uses a chi-square test. You can see that the sample size is 100. The chi-square is 35.625 with a degree of freedom of 2. And then the significant level, the significant value, or otherwise known as the p-value, is 0.000. So this shows a highly significant variation between the way the three questions in section B were answered. Now, where there is significant variation between three or more groups, it is now very good for us to check where this significant lies. Is it between B1 and B2, B1 and B3, or between B2 and B3? Now, to do that, we'll have to further do a post-hoc test. Now, a post-hoc test is used to conduct a pairwise comparison when you're looking at significances among three or more groups. Now, how do we conduct that post-hoc test? The post-hoc test we'll be using is the Wilcoxon Test. Now, to conduct the Wilcoxon test, again, still on this section B, go back to Analyze, again, down to Non-parametric tests, legacy dialog. Now we are going to be looking at two related samples because we want to carry out pairwise comparison. I'll select it. Now, remember that the variables we are using is B1, B2, and B3. So we are going to be feeding it into these test pairs. Click on the first variable, and I'll move in my B1. Again, I'll click on the second variable, move it. So this is the first pair between B1 and B2. I'll come down to pair number 2. Pair number 2 is going to be between B1. So I'll move B1 and also move my B3. Again, for pair number 3, it's going to be between B2 and B3. Now this is all set. We are comparing between B1 and B2, B1 and B3, and B2 and B3 here. Then remember we said our post-hoc test that we are using is the Wilcoxon test. We make sure it is ticked, and then we click on OK. Now we switch to our result menu to also see the results of the post-hoc test. Now in the post-hoc test here, we see this is the first one here is between B1 and B3. The second one is between the first one here is between B1 and B2, while this is between B1 and B3. And the last one is between B2 and B3. You find out that they are all significant. That means there is, okay, one here is not significant. One is not significant. Let's look at that one very well. Okay, it's still significant, but the significant level is not as much as others. So now comparing between B1, B2, and B3, we see that significance is 0.03. Remember, we said it is significant when it is less than 0.05. So 0.03 is significant. However, if you look at this one, you find out that the significant level here is higher when you compare between B1 and B3, and also between B1 and B2. So this is the post-hoc test. This is post-hoc test to check where the significance lies. Remember that the post-hoc test is only conducted where your Friedman test shows significant variation. If the test is not significant, then there is no need for a post-hoc test. So this is simply how to run some inferential statistic on a given survey data. So this evening, we've seen again how to compute descriptive statistic for your survey data, and also how to check for correlation analysis. Let's go back to the results and see all the results we have obtained from this analysis. So firstly, we were able to get our descriptive statistics and also check for frequency and percentage. So the frequencies of how each question was answered. Then after that, we are able to get the correlation between section B up to section E. Each question, how it correlates with how the questions correlate with each other. And we observe that there is both positive and negative and even perfect correlation here. Some are significant at 2%, 10%, 1%, which is ones with double star, while others are significant at 1%. That's why here we have correlation is significant at 0.01 level. That is 1%. It should be double starred. While correlations that are significant at 5% should receive 1 star. So in this correlation table here, we see both 5% significant and the 1% significant. Now, one may want to ask what is the difference between the 0.01 level and 0.05. Now, in statistics, in inferential statistics, when a test is significant at 5%, that is at alpha equal to 0.05, we say that it is significant. But when it is also significant at 0.01, we say that test is highly significant. So 1% significant is higher than 5% significant in statistics. They are both significant, but 1% is said to be highly significant. Then away from that, we use Friedman test to compare between a particular section of the questionnaire. We use section B to check if there's significant difference in the responses of respondents on how they answered the 3 questions. And our test statistic here is highly significant as the p-value is less than 0.001. So this shows that there is indeed significant difference. Now, a post-hoc test was used to check where this significance lies, and we use Wilcoxon post-hoc test to check for that significance. And we'll find out that indeed there is significant difference between all pairs, between B1 and B2, between B1 and B3, and between B2 and B3. So there is all around differences on how the questions were answered with respect to section D. So basically, this is how to conduct inferential statistic on a questionnaire data. Depending on your questionnaire, there are some questionnaires where you have to do a regression analysis. There are some where you have to do, of course, the ANOVA analysis, which demonstrated this line. However, remember we said when analyzing your questionnaire, because the conditions for ANOVA may not be in place, it is best to use a non-parametric test, such as Friedman test, which is used to compare for variation in the same group, or the Kruskal-Wallis test, which we're going to handle in subsequent class, which is used to compare for variation among groups. So that will bring us to the end of our discussion on inferential statistics using questionnaire data for now. Feel free to leave your comments in the comment section, and if it's your first time coming to our channel, do wait to subscribe to our channel to support us so that more videos, while they drop, indicate the notification so that I can always get the videos. Also remember to check out other videos on this teaching series. The series is on data analysis using Excel and SPSS. Now, for you to understand this one, if you're a novice in SPSS, you need to go back and watch our introductory video in SPSS before you can be able to understand this one. Thank you very much.
Thank you for watching this video. You can also check out some other videos that are prerequisite to this one on our course series in data analysis using Microsoft Excel. Please kindly leave your questions in the comment section and we'll attend to them. Also remember to like, share, comment, and most especially please kindly subscribe to this channel so that we can always serve you better. Thank you.